Hello. Yeah, good evening all.
Good evening, ma'am.
Good evening, ma'am.
Yeah, so
Good evening.
last session that we're conducting for this term. So this is an open session, and if you have any doubts somewhere, you can clear it out. You can ask.
Ma'am, I have one doubt.
Okay.
Ma'am, this is like actually simple. It's just regarding how do you choose what is the null and the alternative hypothesis. So from what I did in the graded assignment 10 of
Okay.
that week 10, there is question number 15.
Question number 15. Wait, just let me check.
Yeah.
Share my screen. Yeah, this problem, right?
Yes, ma'am. Ma'am, so in such a problem, how do we decide, like what the answer I had written was for this, that H naught is mu equal to 2.5 and the last option basically. So from such a question, when see a box of a certain brand of washing powder advertises that its weight is 2.5 kg, but the actual weight is 2.4 kg.
Okay,
So now it says the company wants to test. So I don't know how to choose between option 2 and option 1 and 4.
Option 1 and 4. Yeah, so null hypothesis, which generally takes that we assume to be true, right? Whatever it is true, right? So this 2.5 kg, the company has advertises, but what is the actual weight that is given? It is 2.4.
Okay.
Okay. So this is the null hypothesis. Like we know that the actual weight is 2.4, and now we want to test whether the mean has changed, right? So now the company is testing whether the mean has changed. So whether mu equals 2.4 or not, because what the company is advertising is it is 2.5 kg. Right? So null is given to be 2.4 and alternative to be not equal to 2.4.
Not 2.4. Okay, ma'am. Yeah, so there was a small confusion in that which I had. And also in the lecture which professor gave, lecture 10.8, there is a question like the current carrying capacity of a resistor manufactured at your company is supposed to be 3 amps. Because of a recent change in the process, you suspect it to be lesser than 3 amps. So again here regarding the same question of choosing the null and alternative. So H naught, as the professor has said, H naught is 3 amps. So again here, I just wanted to clarify that will there be options which are just the opposite, like H naught is 3 amps and HA is less than 3 amps, mu less than 3 amps, but what do we have an option where it's just the reverse?
Okay, so this problem we are talking about, right?
Yes.
It's supposed to be 3.3 ampere, okay?
Because based on this, our calculations will also just come exact opposite,
So,
like reject or accept.
So what did you take as a null hypothesis here?
No, as I was following the lecture, this was clear to me. But with regards to the previous question, this also came to my mind that if we have in the options, sometimes we are given 4 options. So what if we are given this, the one which professor has mentioned, and the exact opposite, H naught is mu less than 3 amps and the other way around.
Okay, so what we are following in this course is like whatever the null hypothesis is, assume it to be the simple hypothesis. So you know about simple hypothesis, right? Something that is fixed. I mean, it is no inequality sign is there. Like if you look at alternative hypothesis, it is mu less than 3 ampere, right? So
Yeah.
mu can take any value here. If it is mu greater than 3 ampere, again it can take any value. If it is less than equal to 3 ampere, again it can take any value. There is no certainty like what mu is.
Okay.
So like whatever we are doing here, like generally we are assuming the null is the simple hypothesis.
Yes. Okay. Yes.
Okay. So that
So
is why we'll take mu to be, we can just say simple hypothesis.
okay. Yeah. Yes, ma'am. This is clear. Yeah. From our workings, we have always chosen the simpler.
Yeah.
Thank you, ma'am. These were regarding the like a few questions. I just had two other small side doubts. If it's okay, can I just ask it right now regarding the quiz?
Yeah, just hold on. And Nimish Shah had raised his hand. Do you have any doubt, Nimish?
Yes, ma'am. I was asking that concentration phenomenon is coming in N term because it was not there in quiz 2.
No, concentration phenomena is not there.
Okay, ma'am. Churn of inequality is
Yeah,
also not
no.
there.
Yeah,
Okay.
shun of inequalities like is not for your quiz part. I mean, your syllabus particularly.
Okay, ma'am. Thank you.
Ma'am, regarding that only, like the portion which is mentioned, it says from estimation, confidence interval, and mean squared error can be skipped. That's what the mail states.
Yes.
So estimation, you mean like from that estimation section, these can be skipped?
Yeah, confidence interval part and mean square error part can be skipped.
Okay, so confidence interval comes in actually week 9 also. So even
that can also be skipped. Yeah.
Okay, and mean squared error so includes like a bias, variance, risk, all three. That
Bias,
whole
variance, trade-off, like wherever you are finding error, right? That part.
Yeah, that part. Okay, and also direct questions from week 4 and 5 are not there, right?
No, that is not there. No integration part is there.
No integration. Okay. And ma'am, I saw in the discuss forum some people had asked about that formula sheet being handed over to us like in a hard copy.
No, hard copy will not be provided to you. There are some issues, so it will be as usual what you have seen in the previous quizzes.
Okay, ma'am, but is there a possibility like actually hard copy was also not required? It would be easier if it's given like how the calculator appears on every screen. Is it possible to have it like that?
So
And
this doesn't appear. It comes as question number 1, right? Your formula sheet.
yeah, it comes as question number 1. So when we are at another question, we have to go back and the numbers should be remembered that way.
I'm not sure if that can be done. I mean, not at least for this quiz.
Not for this quiz. Okay, ma'am. And this list of options that those type of questions also come?
Yeah, they are not this time. They're not there.
They're not there. Okay. Okay. Thank you so
So
much.
whatever you have seen in mock, the pattern is going to be exactly same.
Okay.
With few easy questions, few medium, few normal.
Steps are not there, ma'am.
Steps are not there this time. Yeah.
Ma'am, the difficulty will be the same, right?
Same as whatever you have seen in mock itself.
Okay.
In the mock. Okay. And even like the questions, the number of questions that.
Yeah, almost
around this.
Yeah.
Almost the same. Okay. Thank you so much, ma'am.
Yeah.
And madam, there is a formula file for quiz. So does that question 1 will have the similar formulas available?
So whatever you have seen on the portal, so if you go to the formula file, there is a formula file for final quiz that you will see in your PCS portal itself.
Okay.
It will come as question number 1 for you. So you can always go back and check the formulas if you don't remember something.
Ma'am, the question which has a list of options, it would be there or not?
No, list of options will not be there because such kind of questions are not there this time.
Okay, ma'am.
Yeah, so it has hypothesis testing as well at 11. There are all formulas are listed.
Yeah, everything is listed there.
Oh, okay. Because earlier I heard that these formulas will not be provided into the exam.
No, formulas are provided. You just check the formula file. It is already there.
Oh, okay. Yeah, thanks. Thank you.
That entire sheet will be just given as the
discussion. Yeah. So Priyadarshi has asked if I can revise hypothesis testing. Can you tell me just what part you are not comfortable with? Like I have already done 2 times in the session. So if you have any doubt in the problems, we can discuss that. Yeah, can you tell me some problem that we can discuss?
Ma'am, that overall approach for the entire hypothesis, various hypotheses like T and psi square chart and all those things, what to look forward for from the problems, and what is that being asked in which of the test model we have to use it, how to approach that one. And I'm very high level. Can you guide us? Some sort of a roadmap.
Okay,
Yeah,
yeah.
yes, ma'am. How to choose the test? Just like in which question we have to use which test. That will be mentioned in question only, or we have
Mm,
to.
No, not always it is mentioned in the question. So you will have to figure out on your own, like what test you would like to use there and what
Yeah.
can be used there. Okay.
So, ma'am, can you
Okay.
just elaborate?
Nikita, I have some specific questions also from the activity question and one topic that I would like to put forward to understand.
Can you tell me the problem number?
Yeah, so problem number 2 from activity question 11.7.
11
Activity 11.7, question number 2.
Okay. Okay.
Then I have put across on discourse also just few minutes ago, but since you are over here, I can again ask that question. When we are doing the sample size calculation,
Okay.
what is the expectation? I mean, 97.41, if the answer is coming, should we write that as 97 or will the correct answer be 98?
Always write the greatest integer.
The greatest integer, I see.
Yeah.
Okay.
Yeah.
Okay. Not going by the concept of if it is 0.5, then choose the lesser one. And if it is above 0.5, okay.
No.
So irrespective, even if it is 97.01, we go ahead and write 98.
98.
Correct?
Yeah, you go and write just 98.
Now,
That is
sometimes they do ask for a floor value, no?
Sorry, can you repeat?
Sometimes
Yeah,
they
that is
do
what
ask
he's
for a floor
saying.
value.
Sometimes it's the exact value that is asked, and that hence my question was also there.
Sometimes it gives the exact. In that case, you write the exact value.
No. Sometimes the expectation is just to write the exact value. It is not a range that you expect, right?
Okay.
That's where I was asking. Even if it is 97.01, we go ahead and write 98.
98. Yeah.
Okay, fine. And another set of questions that I wanted to ask was from 11.6, question number 7.
Okay. All right.
Yeah, and model estimation, I think I said, but I did try to understand the concept of model estimation. The examples that Professor Andrew has taken from example 2, it was like not able to understand much from problem number 2 example that was taken in model estimation specifically.
Yeah, I understand, like it is like very vague in some sense, but these kind of problems are there in your practice assignment or credit assignment. So why don't you just practice those problems? Like, do you have the idea like how to approach such problems? Like if the informative prior is given, how do you find the posterior?
Yeah, so Nikita, I asked the same in the previous session also,
I remember.
right? So while it is absolutely understood, leaving aside solving the questions is altogether a different story, but I have understood the concept of posterior density. Model estimation is altogether different thing that he is explaining. So model estimation as a topic, I'm not able to understand. If we can skip it, then it's okay. If not, then perhaps I would like to get some understanding. Model estimation, specifically the topic is 9.5.
Yeah, 9.5.
And it has nothing, nowhere, at least the posterior density is coming into the picture.
Oh, just wait. just one problem has been done, right?
So problem one, there are three problems. Problem one was okay to understand.
Capture, recapture,
Yeah, capture, recapture was okay to understand. But problem two onwards, I did not understand. What exactly is the goal? What is the purpose? In the first example also, the expected value of M is calculated, but what are we doing? How are we have calculated N over here, but what is it supposed to do with the model estimation?
Okay. So like here we wanted to like estimate the population size. So we have some data, and from there, how will you come to the population size? Like how will you estimate it? So this was a model, and from there you wanted to estimate something, right? So this is basically what we were doing here, like in the capture recapture method, capture recapture process. Right? You have some you have some model, and from there you want to estimate something. So like looking at the situation, we figure it out that it's a hypergeometric distribution. It will follow the hypergeometric distribution, and from there we have used the method of moment estimate.
Yeah.
Like estimate the population size here. And if you look at the second problem here, we had some data about the number of defective items, and we were trying to look at some prior, and from there we're trying to find the parameters of the distribution, and then trying to fit if I'm saying like the fraction was 5% or 15%, 90%, 95%. So all this has been done using the Colab file. This has been done using Colab file, right?
Yes, ma'am.
The last part.
Yes, ma'am. It was done using Colab.
Yeah. So like doing by hand is a little tricky. I mean, you'll have to know all the values before.
So these type of question will not come in the exam, no?
So if the collab is needed, such kind of problems will not come in the exam.
And also where we find like a variance, sample variance, usually we use the collab for that. Because I mean, sometimes when there are many values, the calculation is a little long.
Yes, ma'am. The
so in that case, like even if you look at those can be given in the problem itself.
Okay.
Yeah, I mean, we'll be given the sample variance by itself, right? And
yeah,
not having to calculate. Okay.
Yeah.
But all we have to calculate, you have to divide it by like n-1, right? We are following that.
n-1 sample variance.
Yeah, sample variance. Okay.
So the thing which you are showing in the screen,
yeah,
this is from which topic? From
this is week 9.
Estimation, right?
Estimation, yeah. Right.
Okay. So I have a couple of questions with respect to hypothesis testing. Week 11, tutorial 1, question number 3 and 5.
Tutorial 1, question number 3 and 5.
Yeah.
Okay. Nikita, done with this? I mean, that is what you wanted to say, or anything else?
No, I think we had discussed quite a lot last time also this one. So like if you, like in case of the modeling problem, right, you can just go with the informative prior type of problems. It's basically this is what we are doing here. Okay. If you know to solve how to such kind of problems, it will be enough.
So what you mean to say is we'll be provided with the prior distribution.
Prior distribution
and some samples.
Yeah, right.
So that is more better. That is better to practice rather than spending time on these problems, right?
Yeah, so here it is, the prior was not given, we had selected something on our own and went with. So that
Fine.
cannot happen in the exam. Right?
Okay. Nikita, before taking this question, if you can pick up what I asked, 11.7 question number 2.
I have it. I will. So first I will go by activity and then go to tutorial.
Okay.
Just let me check.
Excuse me, ma'am. I just had a small doubt. MGF, the moment generating function, is in the syllabus, right?
Yeah, it's in the syllabus, right?
Okay. Because ma'am, actually, there were no questions in the mock, so that's why I just wanted to confirm.
Yeah, like we cannot give everything. So, just 40 marks. Paper.
Thank you, ma'am.
Yeah.
Sorry, ma'am, I wasn't able to hear. What did you just mention right now?
No, somebody asked if MGF is in the syllabus for quiz, final quiz.
Okay. So it's not there, right?
It is there. In week 7, we have told, right? Week 7 is there. So in week 7, except the concentration phenomena, that is turn-up bound, you have to study. Okay.
Ma'am, we have for week 4, 5, 6, right?
Week 4, 5, 6 is.
Okay, ma'am.
4, 5, 6, like the questions are not there definitely, but yeah, whatever you have studied the topics there, I mean, it will be used. It is used in the later weeks, like week 9, week 8. So you should know what it is. Like the direct problems will not go.
All right.
So 11.6, question number 7. This one. So here it says a fast food shop has been averaging about 2,000 of business per day. To see whether business has slowed down due to deteriorating economy, management has decided. Okay. So what we want to check is whether mu is 2,000 or not, right? So our alternative hypothesis is mu is less than 2,000 because we want to check whether the business has been lowered down. So if it was initially 2,000 rupees, then has it gone below 2,000, right? This is what we want to check. So this is our null and alternative hypothesis. Now the next thing that come is, are the data significant enough at the 5% level to prove that a change has occurred? So our alpha is given to be 0.05. Now we want to check whether the change has occurred or not, right? So what is our test? Test is reject H naught if your test statistic is going to be less than C, right? So how do you write alpha? It is going to be 0.05 equals probability. Can you mute yourself? Yeah. So it is going to be probability that you reject H naught. So when are we rejecting H naught? When P is less than C. Okay. Given given H naught is 2, that is mu equals 2000. Now, what is T that we can take here? So T we can take as X bar. Let's take T equals X bar. So X bar is less than C given mu equals 2000. Now we have to convert this X bar to the normal Z01 form. So do we have the standard deviation given here? We don't have the information, but we have a data, and from there we know the sample standard deviation is S equals 120.18. So we'll subtract this by 2000 and then divide it by 120.18 divided by 8. So divided by root 8.
Root 8.
Yeah. So this is going to be less than C minus 2000 divided by 120.18 divided by root 8. And this is going to be FT.
Excuse me.
Yeah.
Can you explain denominator? I can't understand.
Okay. So see. X bar was your random variable here. Okay. And what is the mean of X bar? Like, let's say if I have x1 to xn samples, let's say these are IIDX, and I have defined X bar, that is sample mean x1 plus x2 plus xn by n. So what is the mean of X bar? How do you write expectation of X bar?
I didn't get this, ma'am.
Okay. So, so do you know how to normalize any random variable? Was asking.
No, ma'am. I am not able to get this. Can you explain?
Okay. Have you gone through these weeks, week 10, week 11 before?
Yes, ma'am.
You have gone through it. Okay. So what is your alpha? I will just write it here. So what is your type 1 error says? What is probability of type 1 error? So probability of type 1 error is given by alpha, that says probability that you reject your null hypothesis.
Yes, ma'am.
If
Given.
Given H naught is true, right?
Yes, ma'am.
Now what is H naught?
Mu is equal to 2000.
Mu equals 2000. Why mu? Why we have written mu equals 2000? Do you know how we took the null hypothesis? Do you have problem in understanding the null and alternative hypothesis?
Yes, ma'am.
Yes. So okay. So in the problem, what it was saying is, like a shop who has like recorded the average business per day, and it says like per day he is able to get some 2000 rupees. Okay. Now he wants to check whether his business is like going down. Okay. That he want to check. So what is it that he wants to check? So it is mu is equal to 2000. Now he wants to check whether it has gone down from 2000, right? So mu should be less than 2000. This is what it wants to check.
Yes, ma'am.
Right? So this is going to be an alternative hypothesis. Now, how to decide reject H naught? So H naught was mu equals 2000 and HA was mu less than equal to 2000.
Yeah. Okay, ma'am. Okay.
So test statistic that is given by t, that let's say I have taken it as x bar because we had two tests for mean. I can just take x bar as test statistic. Now the test says that reject h naught if x bar is less than c. So you just look at if you have problem in understanding this, what you do is like just check HA. So if the symbol is less than something, you just use less than in also in test. So I will say reject H naught if x bar is less than C. So x bar is less than C given mu equals 2000. Now I have to convert this x bar to Z. And to do this, I will have to subtract x bar by its expectation and divide by its standard deviation of x bar. Okay, this is what we do to convert this x bar to the normal 0, 1. So what is the expected value of x bar? If let's say I have x1 up to xn, which is IIT x, and it has some mean mu and variance sigma square, let us say. Okay. So expectation of x bar is given by mu itself and variance of x bar is given by sigma square by n. Now in this problem, we did not have the population variance. So what we did is we had a sample, and from that sample, we calculated this sample variance. And from there, we used sigma square by n thing. So this is variance of x bar is sigma square by n. So standard deviation of x bar will be sigma upon root n. So this is what we have done here.
Okay, ma'am. I got this.
Yeah, try many problems. Then it will be more clear. Okay. So okay, so what does this become? This becomes ft of how many degrees of freedom? It is 9. C minus 2000 divided by 120.18 divided by root 8, and this is equal to 0.05. So what is the t value that is given? It is minus 1.89. So minus 1.89 equals C minus 2000 divided by 120.18 divided by root 8. So from there you can find the value of C. Can somebody tell me what is the value of C they are getting?
1920.
Actually, it's only a yes or a no, right?
1920.
1920. Okay. Yeah, so now we'll have to check whether we are rejecting H0 or accepting H0. So what is the sample mean that we are getting from the samples?
2082.
2082. So we can clearly see that this x bar is greater than C. So we cannot reject H0, right? So if we cannot reject H0, so what we have to check is like, are the data significant enough at the 5% level to prove that a change has occurred? So since we cannot project H0 here, right? So it means the change has not occurred.
So we accept H0.
We accept H0, right?
So change has not occurred, right?
Change has not occurred. So the question says, do we have enough evidence to prove that a change has occurred at the 5% significance level? So you don't have enough evidence.
Fine. There was some confusion between hypotheses towards the end, but yeah, now it's cleared.
Okay.
And Nikita, 11.7, question number 2. I mean, yeah, you don't have to solve it, just one question that I'll put it.
Okay. Diameter of rings.
Yeah, so what my question is over here, you want to read it or should I ask my question?
You can ask the question.
So over here, why are we not taking the sigma value as the population standard deviation itself.
Sigma value as the population standard deviation.
Why do we have to do that calculation of sigma 1 square upon n plus sigma 2 square upon n that we do usually for the Z test, right?
Okay,
So
okay,
why
this
can we
is
not
two
take sigma
sample,
1
yeah.
square?
This is what we have been doing, right?
Yeah, because the test statistic we are considering is not the entire population, right? We are considering X bar minus Y bar.
Yes.
And for that, if we find the variance of X bar minus Y bar,
yeah,
then
right.
it will
It
come to
comes
that.
out to be sigma square by n1 plus sigma square upon n2.
Okay. Then in this question, I mean, we just have given one sigma. Diameter of rings manufactured in the company have a standard deviation of sigma equals 10 centimeters.
Yes, right. So, sample average is given to you.
(15 and 18).
Oh, yes, sample average is given. Yeah, so it just one segment.
If you don't mind, then you may want to solve it.
Yeah, okay. Somebody has raised hand. Aziz and Mangaleshwar. You have any doubt?
Yeah, ma'am, I just have doubt on another question, not this exact question actually.
Okay, okay. I will come back to you.
Ma'am, if you don't have any questions, can you get back to the request what I made? How to really approach the whole sample framework?
Let's do like I had couple of questions. Like another two questions are from Samra. So after that, we'll see. Okay.
All right. Thank you.
So it says diameter of rings manufactured in a company have a standard deviation of 10 centimeter. And suppose a sample of 50 rings. So N1 equals 50, N2 equals 50. Sample average of 15 centimeter and what is 18 centimeter. Average diameter at a significance level of 0.05. So alpha is given to be 0.05. And the null hypothesis is mu1 equals mu2 and the alternative is mu1 not equals mu2. So what is the test statistic that we're taking? We're taking it to be x bar minus y bar. Now the test says reject h0 if mod of x bar minus y bar is greater than say. So this follows your t, that is x bar minus y bar, follows a normal distribution with mean 0 and variance sigma 1 square upon n1. So it is 100 upon 50 plus 100 upon 50.
So exactly, this was my question. I mean, why have we taken 100 by 50 when we have been given just sigma? Do we consider it for N1 also and N2 also?
Yeah, because this is your test statistic, right? So x bar minus y bar is your test statistic, right?
Mm-hmm.
So given the null hypothesis is true, like if you want to find the expected value of this, right? So what is this going to be? This is going to be expected value of x bar minus expected value of y bar, right? And expected value of x bar is given by mu, and expected value of y bar, if it is given by mu2, right? Then it is mu1 minus mu2. And if null hypothesis true, it comes out to be 0, right? And if I want to find the variance of x bar minus y bar, this is going to be what? This is going to be variance of x bar plus variance of y bar, right? So what is variance of x bar? It is going to be sigma 1 square upon n1, and it is going to be sigma 2 square upon n2.
Right.
Right. So in this case, both sigma and n are same. Correct. So this is just 2 times sigma square upon n. I can just write. So in case of one sample, why we are just taking sigma 1 square upon n1? Because we just have like one sample there. But here we have 2 samples and we have taken our test statistic to be x bar minus y bar. So that is why you will have to do it 2 times. We cannot just say that the variance of x bar minus y bar is sigma square upon n.
Okay.
Because you have the test statistic as x bar minus y bar.
Okay. This explanation was needed. After that, I mean, it is just putting the formula so that can be solved. Fine.
Okay. Yeah.
Fine. Thank you.
Ma'am, can you continue this one? Just I want to know how to evaluate alpha.
How to evaluate alpha? Okay.
Okay,
So
the remaining calculation. I have the same
sigma
doubt.
square is coming out to be what? This is just going to be, this was standard deviation, right? So 100 upon 50, that is going to be 2. So 2 times 2, that is 4. So this becomes your 2 square. Okay. So this distribution of t is normal with mean 0 and variance 2 square. So if you want to find alpha, this is 0.05. Now this is probability that you reject H0. So mod of P greater than C given mu1 equals mu2. So in this case, it becomes x bar minus, this is x bar minus y bar greater than C given mu1 minus mu2 equals 0. And this is given mu1 minus mu2 is 0. This becomes x bar minus y bar divided by sigma, like it was 4, right? Greater than C upon 4. That is 2 here. Okay. So this
here we are not subtracting mu from numerator as we are doing in the previous.
Why? Because we have our test statistic is what? X bar minus y bar, right?
Yeah.
This is our test statistic. Now, what is the expectation of expectation of t given that mu1 equals mu2, right?
Okay. I understand.
It is going to be 0. So it is
says 0, so it's a t minus 0 doesn't affect t minus 0. Yeah.
So this becomes probability mod of z greater than c upon 2. Fine. And this you can write it as probability z less than 2 times probability z less than equal to minus c upon 2. Fine.
After that, I know I have that much doubt only that we are subtracting 0.
Okay. Fine.
The same thing is there in the question number activity 10.8 question number 2. I think
10.8 question number okay. 10.8.
10.8 question number 2.
Okay.
The mean lifetime of sample of 121 fluorescent light bulbs. So something this question is there.
Yeah. So what is it out there?
Here
yeah, so it says the mean lifetime of a sample of 121 fluorescent light bulbs produced by a company is computed to be 1380 hour, right?
Yeah.
And the standard deviation of 100 hour. If mu is the mean lifetime of all the bulbs test the hypothesis that mu equals 1400 against alternative that mu not equals to 1400 using 1% level of significance.
So here also we have to subtract mu, na? T minus mu by
So, see.
sigma by root n.
Let's say
H by root n.
H naught is, let's say mu equals 1400, right? Yes.
Yeah. H naught
And
is
H
mu equal to
is mu not equals to
1400. Yeah.
Now I'm taking my test statistic T to be X bar, right? I'm taking my test statistic to be X bar. Now the test says that reject H naught
H naught is true.
if mod of T minus mu.
Yeah, mod of T minus greater than C.
Yeah. So why do we have this? You have doubt in this, right?
Yeah.
Yeah.
While
So,
evaluating alpha value.
yeah. So if I want to find alpha, this is going to be probability that mod of T minus mu greater than C given mu equals 1400.
Yeah.
So why do we not subtract mu from here? This is what you want to know.
Yeah.
Let's say this is a distribution of X bar and this is your mu, right? Now this is a two-sided test.
Two-tail test.
Two-tail test, right? Now, if you evaluate this, you will get T greater than mu plus C and T less than mu minus C.
Yeah.
Basically, what is alpha? Alpha is these two combined value, right?
Sum of these two areas.
Sum of these two. So this expression represent this area only.
The sum of these two areas.
Yes.
Shaded region.
Yes. This is your C, this is mu plus C, and this is mu minus C. So T greater than mu plus C is this, T less than mu minus C is this. And these two combined give you what? Alpha.
Yeah. So the left part is alpha by 2, right part is alpha by 2.
Yeah, right.
So if you evaluate that, okay, so we do.
Evaluate it.
So we
You
need.
just try.
No, yeah, no need to subtract mu value from C.
No need.
Okay, that's a doubt. Yeah, that's clear.
So the next was
Yeah, one more, last one. The same activity, question number 1. So here the probability is given in terms of percentage. That is 90%.
Okay.
Okay, and the sample is also given as a 200. So n what we have to take, n as a 100 or n as a 200 while solving the example. Means while evaluating the standard deviation.
Did you try to solve this?
Yeah, I try to solve it.
So
but I'm getting confused in between evaluating the sigma value. Sigma by root n is there, na? So whether we have take n as a 100 or 200, because the claim is 90%. So the probability you can say P is 90 by 100.
Okay, so it says the manufacturer of a new medical drug claimed that it was 90% effective.
Ma'am, this discussion is really going blind. In fact, we are not reaching out to the question where the question doubt is raised, and it is becoming one-on-one discussion where the rest of the people are just blind.
Okay, I will. Okay.
I mean, this is not effective.
Yeah. So my question, specific doubt is that.
No. Okay. Let's reach out to the question first. No, just can someone project it?
Yeah. Activity 10.8, question number 1.
Wait, I will share.
Yeah, this helps a lot.
Okay. Yeah, thank you. So, okay. So, does anybody would like to explain this first problem? So his doubt was
My doubt is that here the sample size is given as a 200. Okay. And while evaluating the sigma, we are taking it as 100. So why we are taking it's 100? It is given as a 200 sample size.
yeah, anybody would like to explain this? So the problem says that
So I'm not comfortable about the doubt here. So the
yeah,
200 is given to calculate the probability. So 150 by 200.
right.
150 by 200 is 0.75, which is lower than the
It's an observed value. No? For evaluating that observed value, we are using 200.
so alternate hypothesis is less than 0.9. Is that true?
Alternate hypothesis? Yeah, less than 0.9.
Alternate hypothesis less than 0.9.
Yeah, that is true.
Yeah, that's true. But my specific doubt is that while evaluating standard deviation, whether we have to consider 200 or 100, because the 90% is given here. So out of 100, we are taking 90 samples, I think. So that's why it's a 90%.
How do you find the standard deviation? Like, how will you find the standard deviation?
No, first of all, this is not about the standard deviation, right? This is the probability of success. 90%,
yes.
it is. You have to consider that the medical drug is claimed to be success. And out of the sample 200, 150 are relieved. So in the sample of 200,
No, 150 is not relieved. 150 is administered.
Sorry?
No, out of 200.
150 is provided relief for 150 people out of the 200 people taken as a sample.
No, from out of the 200, the medicine provided relief for 150. So the probability of success here is 150 by 200.
Yeah, that is right.
See, starting with this particular kind of sum, thing is simple. So null and alternative are clear now. Regarding what is null, what is alternative are pretty clear. I'm correct now?
Yeah.
So null is x bar equal to 90. Alternate is x bar is lesser than 90. And we are going to find that particular threshold for this particular problem.
Yes.
And and the sigma for this particular problem would be, this is a binomial distribution. Binomial Bernoulli.
Yeah,
Bernoulli.
like each of the patient.
P into 1 minus p divided by n. Root of p into 1 minus p divided by n would be your denominator. And c minus whatever x bar, that's going to be 0.9. So based on that, if you do that f of z, and I think this is going to be, claim is not legitimate. It's quite apparent.
Yeah. The answer is that not legitimate. So it's we have to consider it's a Bernoulli. That's why we are taking 100.
Yes. So Bernoulli. So it's just 1 or 0, correct? Now either the patient gets relieved or he is not relieved. So it's either a 0 or a 1.
Yeah.
So that's p into 1 minus p variance.
Yeah, it's clear. Thanks.
I have a doubt in this problem. For null hypothesis, we consider it as 90. For alternative, it is not equal to 90, right?
No, it's a
less than 90. Less than 90.
How come it is less than 90? They have not mentioned, no?
I think the reason is that it's a 150 by 200, so it's a 0.75. The sample is, if you evaluate this from the sample, if you take a ratio, it's a 150 by 200. So it's a less than 90.
Yeah, if it's below 90, then it's not effective, basically. If it's above 90, then it is more than effective. So we should not consider that situation.
This approach is correct, that we have to consider the sample, and based on the sample for this problem, suggest the alternate hypothesis.
Yeah, so your what you said is right only. So wherever for hypothesis testing problem, will be provided basically two values, like to consider the null hypothesis and alternate hypothesis. Whether it will be provided as a sample or that will be provided by words. The whether someone is thinking that uh, it is higher or lower, some wordings will be given. Based on that, we have to take the alternative.
Okay, thank you.
Yeah, thanks, Amrash, for the explanation.
So, ma'am, can I go ahead, ma'am? Same 10 tutorial 2, same activity, ma'am. 10 below, ma'am. Can you just go a little bit up, ma'am? No, ma'am, a little bit up in the left side. So it's 10.2 alpha beta problem, ma'am. So yeah, week 10.
Okay. Yeah,
ma'am. Tutorial, 2, ma'am. Week 10 tutorial 2, non-grade.
Okay.
So, ma'am, I'm able to solve this sum. I got the answer, but use FZ, that's directly given. Hence, I'm able to answer. I was present in one of the week, ma'am, week 11 actually, where they actually did 1 minus beta for this power. But actually, I'm confused.
Power is 1 minus beta, and type 2 error is just beta.
Okay, ma'am. So, ma'am, I'm actually confused between these 1 minus beta and actual beta. So if they actually give us a sum, how do you figure out? Is there any peculiar way, ma'am? Is there any key like some?
No. Here what is given? Here it is power is given. Power is 1 minus beta.
Okay, ma'am.
Power is given, right? Power is given as 0.90. So power we define as 1 minus beta, and beta is a type 2 error. So how do you define power? Power is defined as given the null alternative hypothesis is true, you still reject the null hypothesis. Given the alternative is true, you reject the null hypothesis. And beta is defined as given the alternative is true, you accept the null hypothesis.
Null hypothesis. Okay. So whenever they give
so
power,
you have to keep that in mind. Power is defined as 1 minus beta, and type 2 error is defined as beta.
Okay. So power is basically given null is I mean, we accept a null given alternate is actually true. Correct, no, ma'am?
No, you'll be rejecting null while the alternate is true. That is the problem.
Given the alternative is true, you are rejecting null. That is power.
Okay, ma'am. Alternative is true and reject null. Right. Done.
Yeah.
Okay.
Yeah. Look at the definition carefully.
Yeah, sure, ma'am. I mean, so this is going to take a toll, ma'am. Seriously. Here directly that FZ, that value is given. So for this particular sum,
yeah, so
hence I was
in the
able
exam,
to.
the FZ values will not be given to you like this.
Yes, like this. Yes, yeah. Ma'am. So it's going to take
in the
some.
Exam, we won't have this subscript, ma'am. This T9 or C square, chi-square. Those subscripts won't be there in the exam, right?
Yeah, like those will be given, right? Like if the problems come from these topics, like these values will be given to you.
It will not be given directly in the question. It will be provided separately.
Separately on the top.
But once we know, it's very direct, right? Like once if it's given, then we'll know exactly what test to use. So it's like
but you may get some multiple values.
So when during the last quiz, actually we had just only one question of Z, and we were given 9 values. So it's not going to be an easy task to pick one.
Yeah, so you will have multiple values given. So it won't be very obvious.
Is it possible to sort that in some fashion, like first Z square, chi-square, then Z, then T?
Sorry, can you repeat again?
So is it possible to sort that values, the chi-square values and Z inverse V values? like all the chi-square values first and all the z values, something like that. So whenever we want to search for the value, then it will be easy, right, to pick that.
Ma'am,
Yeah. So the way you have seen in the mock that it is given in a table.
Okay.
So something like that will be provided.
I think
Okay.
that if you people share the table, normal curve table, F distribution table, and chi-square distribution table, and if you, it's better if you explain how to search the values in the table. It's a better from a student point of view. So we can.
Yeah, again, we cannot provide you the table during the exam. Like the hard copy, basically. It's
not the hard copy. As you are sharing the, you can say, formula sheet as a question one.
I believe that is going to be more difficult.
If something in the real life or in other problems, if we are solving, then we are again stuck in that how to find this value, because here directly we are providing the value.
Yeah.
Internet is providing everything, I think.
Yeah.
But for other questions, while solving the other questions, we are not getting the value.
Basically, like when we are doing the assignment at home, like you can always search online, or you can use the Colab file and you can get the values. So it's not so difficult to do that. So in exams, I just generally give.
Ma'am, can
we'll
you
think about it? Yeah.
Explain that in which question we use which test? I'm very confused in that.
Yes, I will come to that. So yeah, Samraj, you had asked tutorial 1, question number 3 and 5.
Yes, Nikita. Yes.
Yeah,
so there, so I thought the alternate hypothesis is mu less than 25 for question number 3 because of the wording. So
the average diameter of pipes is which is suspect to be too low. You thought the alternative is?
It is mentioned, it is intended to be informed. The alternative is less than mu, suspecting less than 25, but I thought the other way, like the average diameter of the pipe is suspected to be very low. So by that way, there's a chance of considering this as inverse, right? Mu is less than 25. Getting my point?
Yeah. So here it says you suspect it to be
the same
too
applies
low.
for the next problem as well.
Yeah, so here we suspect that it is too low. Like you have observed it is like reported to be 25 and you suspect that it is low. So what you want to check is that it is high, right?
Alternate hypothesis will be greater than 25.
Yeah, because you have suspected it to be too low. So you want to check that it is greater than 25. Same in the next problem.
5, question number 5.
Yeah, okay, this is 4. Okay.
Yeah, thank you. That's it.
That's it?
Yeah.
Okay, yeah.
Thank you.
Yeah, so I will go back to all the tests now.
So one small request. So after this, after completing all the doubts on hypothesis testing, is it possible to cover something on the model estimation? Because personally, I feel quite difficult on that, on those topics.
We can go back to the estimation part.
Ma'am, in exam, we won't have any questions from that part.
So what we have studied in hypothesis testing, we have 5 different tests that we studied here. So we have Z-test, T-test, chi-square test, 2 sample Z-test, and 2 sample F-test. So Z-test and T-test, can you mute? So for test for mean, we have Z-test and T-test. These are the tests that we are using for testing the mean. And if we have to test for variances, like if we have 1 sample, in that case we are using the chi-square test, and if we have 2 samples, we are using the F-test. And if we want to test the mean for 2 samples, we are using the 2 sample Z-test. So what happens in Z-test is, like you have we assume 2 samples that is from normal distribution, and the variance will be known to you. The population variance will be known to you, and expectation of X is given to you as mu, and variance of X is given to you as, sorry, this is sigma square. Now, in case of Z-test, you can consider 2 of the test statistics, either the sum of the samples, that is x1 plus x2 plus up to xn, or you can consider it to be the sample mean. Okay, and after once you decide your test statistic, you will have to decide your test. What is the test that you are going to use? So once you have decided what is your null hypothesis, what is your alternative hypothesis, so the first thing that you should always look for is decide H0 and HA. Second is you decide your test statistic. T. And the third is what is the test that you're going to use? Like in what condition you are going to reject your test statistic or accept the reject the null hypothesis. So the third is test, and using the significance level, use alpha to find C, to find the critical value. So once you have decided your null hypothesis and alternative hypothesis, and in case of Z-test, where you're testing for the mean, you can take any of these 2 test statistic, either the sum of the random variable or the sample mean. You have 2 different kind of tests. One is one-sided test, and other is two-tailed test. So in case of one-sided test, you have one right-tailed test, and other is left-tailed test. So what is right-tailed test? It is like the null will be given as something as H0 equals mu naught, and alternative will be given as mu greater than mu naught. So at mu naught, you have the center of the distribution, center of the normal distribution, and you are taking your alternative to be mu greater than mu naught. I can take my test statistic to be X bar, sample mean, and I will take my test as to check H0 if the test statistic value, that is X bar, comes out to be greater than this comes out to be greater than this critical value. So if this happens, if the test statistic value comes out to be greater than C, it means it will lie in the rejection region. So we will reject our H0. So once you have decided your test, you will use your alpha to find the critical value. Okay, or if the critical value is given to you, you can find your alpha. So this is the fourth thing, like fourth step that you usually do. So alpha is given as probability of type 1 error, and it says that given your null hypothesis is true, you know that your null is true, still you are going to reject H0, and by doing that you are making an error. So that probability is given by probability of termed as probability of type 1 error, and this is your alpha. So when are we rejecting H0? We are rejecting H0 if the t value, the statistic value, comes out to be greater than the critical value, given null is true. So if I take t to be X bar, if I take xt to be x bar, so x bar minus mu naught, because I have to now convert this t to the normal z distribution, that is normal 0, 1. So I will have to subtract the mean of x bar and the standard deviation of x bar. So I will have to subtract the mean of x bar from x bar and divide by standard deviation of x bar. So given the mean is mu naught, I can write I can subtract this x bar by mu naught and divide by sigma upon root n, because the variance of x bar is nothing but sigma square by n. So if I have to take the standard deviation of x bar, what it will come out to be? It will be sigma upon root n. So this is what we are doing here. So similarly on the right hand side, we will do c minus mu naught upon sigma upon root n. So this becomes probability is z greater than c minus mu naught divided by sigma upon root n, and it will be written as 1 minus f z of this term, right? So from there you can easily find your critical value, and if the critical value is given to you, you can find the alpha, like what alpha has been used. So this was the right tail test. Similarly, you can do the left tail test, where you will have something like in place of mu greater than mu naught, you will have mu less than mu naught. So you will get the rejection region on this side, and this is your alpha. And the way you have found the critical value in case of right tail test, similarly you will do for the left tail test. And in this case, your test becomes reject h naught if t is less than c. If this is your critical value, and if your t lies in this rejection region, you will reject your null hypothesis. Okay. So in that case, probability of type 1 error becomes probability t less than c given mu equals mu naught. And in that case, it will be just f z of c minus mu naught upon sigma upon root n. So both the right tail test and left tail test can be solved like this. But if you have a two-tailed test, so two-sided test, in that case, our null hypothesis is that I take mu equals mu naught, and we take alternative as mu naught equals to mu naught. So this is our null and alternative. So first we have to identify this, and the second is we identify the test statistic. What is the test statistic we are going to take? So in two-sided, like for for two-sided test. Okay, I came to wrong side. I will just do it here. Okay, so if you have a two-tailed test for test of mean, z test, two-tailed test. So in this case, we take h naught to be mu equals mu naught, and ha to be mu naught equals to mu naught. The test statistic is again x bar, and the test we say as reject h naught if mod of x minus mu is greater than c. So if we have to find alpha, that is type 1 error, so this is given by probability that you reject h naught if given mu naught is true. So reject h naught. So reject h naught given h naught is true. Now I will have to just substitute mu equals mu naught in place of mu. So it becomes x bar minus mu naught greater than c. And to convert this mod of x bar minus mu naught to the normal set 0, 1 form, we'll have to divide it divided by standard deviation. So it becomes mod of x bar minus mu naught divided by sigma upon root n. And the same thing we'll divide on the other side, that is sigma upon root n. So this is probability mod of z greater than c divided by sigma upon root n. And this is written as 2 times probability z less than minus c upon sigma upon root n. Right? And you can write this as 2 times epsilon of minus c upon sigma upon root n. Okay. So this is what we do when we have a two-tail test. The same thing we do for the t-test. So in case of t-test, in what we have to just do is, in place of sigma, we just write s. So here we have sigma. So if we have t-test, we will write just s, that is sample standard deviation. We write s, that is sample standard deviation. So what happens in case of t-test is, like again, we use the t-test for testing of mean. But in that case, even though the samples are from a normal distribution and it has a mean mu naught and variance sigma mean mu naught, but variance is unknown, like population variance is unknown. In case of z test, our variance was known, but in case of t test, our variance is unknown. So what we do is, whatever sample we have observed, from there we find the sample standard deviation, that is small s, and we use that sample standard deviation in place of the population standard deviation, and except that all the calculation is same. So in place of sigma here, I will just write s here, and everything will be same. In place of z test, you will have just t test. And the t values will be provided to you in the problem so that you can use for solving it. Now, after the testing for mean, we have the testing for variance, that is chi-square test and the F test. Okay. So yeah. So what we do, like when do we use chi-square test? Now, whenever you have to test for variance and you have one sample given, so you will use the chi-square test. So you have n IID samples coming from a normal distribution with mean mu and variance sigma square. And you want to test whether your standard deviation sigma is equal to sigma naught. And the alternative can be either sigma greater than sigma naught or sigma less than sigma naught or sigma not equal to sigma naught. In case of chi-square test, you take your test statistic value to be n minus 1 s square upon sigma square. What is s square here? So s square is the sample variance. S square is the sample variance. So you will have some samples given to you, and from there either the sample variance value is given to you in the problem or you will have to calculate it. So this is your sample variance, and sigma square is again your population variance. So that will be given to you in the problem. In case of chi-square test, we take our test statistic to be n minus 1 s square upon sigma square. And we decide the test on the basis of what, again, the way you have been deciding for Z test. So if my alternative hypothesis is, says that sigma is greater than sigma naught, so the test will be reject H naught if S square is greater than C square. Okay. So what is S square here? So S square is again what I said, sample variance. So this is our test. And if your H naught will be true, so what is H naught? H naught is sigma equals sigma naught. So if your null hypothesis is true, your n minus 1 S square upon sigma naught square will become the chi-square distribution with degrees of freedom n minus 1. So if you have n samples, your degree of freedom becomes n minus 1. And the way to solve is again this very similar as what we have been doing before. So again, alpha equals like probability that you reject H0 given H0 true. And when are we rejecting H0? In this case, we are rejecting H0 if S square is greater than C square. Okay. And given sigma equals sigma naught. And we want to convert this S square to this chi-square distribution form. To do this, we'll have to multiply this S square by n minus 1 and divide by sigma naught square. So this is going to be probability n minus 1. If we have n sample, it is n minus 1. S square upon sigma naught square. And the same thing we will do on the right hand side. So this is going to be n minus 1 C square upon sigma naught square. So this term here becomes the chi-square with degrees of freedom n minus 1. And we can write this as 1 minus f chi-square n minus 1 of n minus 1 C square upon sigma naught square. Now given alpha, given some alpha, you can always find the C value. Similarly, you can do for the left, the other side also. The process is same. Now, if you are given two samples, so in that, if you're given two samples and you want to test for variance, in that case, we use the F-test. So if you have, let's say, n ID samples that is coming from normal distribution with mean mu1 and variance sigma 1 square, and you have another samples y1 to yn that is again coming from IID normal mu2 sigma 2 square, and we want to test whether the variance of these two samples are same or not. We want to test whether H0 that is sigma 1 square equal to sigma 2 square, and the alternative can be sigma 1 square greater than sigma 2 square, sigma 1 square less than sigma 2 square, and sigma 1 square not equal to sigma 2 square. So again, a one-sided test and two-sided test. In case of F-test, what we take our test statistic is, we take the test statistic, T to be equal to Sx square upon Sy square, or let's say we can also take Sy square upon Sx square. So if I take my test statistic to be Sx square upon Sy square, then this distribution will follow the F distribution with degrees of freedom n1 minus 1 and n2 minus 1. So what is n1 here? N1 is number of samples in number of samples in the first case, and n2 is number of samples in the second case. So n1 minus n1 and n2 minus n1. But if I take my test statistic to be Sy square upon Sx square, in this case, this distribution becomes like F distribution with degrees of freedom n2 minus 1 and n1 minus 1. So how do we decide which test statistic to take? You can choose anyone you want. Okay. Now, if I want to, let's say I want to test for this one, sigma 1 square. So our H0 is sigma 1 square equals sigma 2 square, and HA is sigma 1 square greater than sigma 2 square. So let's say I am taking my test statistic to be Sx square, or here I will just write S1 square upon S2 square. So if I take my test statistic to be S1 square upon S2 square, so I will take my test to be reject H0 if S1 square upon S2 square is greater than 1 plus CR. But if I take my test statistic to be S2 square upon S1 square. In that case, my test will become reject H0 if S2 square upon S1 square is less than 1 minus CL. So you can choose any test statistic you want, but whatever test statistic you choose, you will have to decide your test accordingly. And after you decide your test statistic and your test, you can find your alpha that will be given by, let's say I'm going with the first one. The first one.
Excuse me, sorry to
Yeah.
interrupt.
Yeah.
But in the formula sheet which has been shared, ma'am,
Hmm.
for the F test, both are denoted as S1 by S2 square only.
Both are denoted by S1 by S2 square only. Wait, let me check.
He meant both the left and right.
Yes, exactly. That's what I meant.
Let me check.
Yeah, similarly for the other one as well, the same applies. We can consider S1 square by S2 square or S2 square by S1 square. Based on that, the values will change.
Yeah, right. So is there anything wrong in formula 5?
Another one query is there.
Oh, wait, just let me check. I'm just checking.
The formula sheet is not having anything on the tests. Am I really referring to wrong formula sheet?
Formula sheet has the test.
No, the link given in the chat box. We don't have.
Yeah, so in this case, like depending on the test statistic, the rejection reason has been decided. So you can take anything you want. That's what I said. Like test statistic, like if you I just share the screen. Yeah. So if you look over here, so it says for the first case, sigma 1 equals sigma 2 and sigma 1 greater than sigma 2. So if you take T to be S1 square upon S2 square, then you will reject your H0 if S1 square upon S2 square becomes greater than 1 plus CR. But if you take T to be S2 square upon S1 square, then in that case you will reject your H0 if S2 square upon S1 square becomes less than 1 minus CL. Depending on the test statistic, what I meant.
In the sheet, it is given as S1 square by S1.
Yeah, it is just one test statistic. The other test statistic can be S2 square upon S1 square also. Okay, so to avoid confusion, you can just stick to this if you're not very comfortable with that right now. Maybe you can just follow this and proceed.
Which condition has to be satisfied for that two-tailed test? Like they have mentioned as or no. Whether we have to check both
you
or
will have
only
to
one?
look at the problem and then decide in that case. So if you look at some problem, wait, share that.
If the ratio is more than 1, then we have to take 1 plus R, CR something.
Yeah, right. But again, that depends on the like the test. Okay, just let me see one problem. In the practice assignment.
Ma'am, this is the formula sheet we will be getting. Because there are two different formula sheets are there. One is very truncated one with just eight or 9 formulas, and the one what you are showing it is a detailed one. So are we going to get this detailed one?
Yes, formula file final quiz.
Okay.
if you look at, if you go to the formula file, the first file is formula file final quiz. This is what you will get.
Thank you, ma'am.
Yeah. Am I sharing my screen?
No, no, nothing is shared.
Okay. Okay, so here you had one problem in the practice assignment, where you have a 2 sample F test. Okay, so the test statistic, you can again, like, you can either reject H naught if S is square upon SP square is greater than 1 plus CR, or the other way. Okay? Now you look at the values that are given, like S square upon SP square value, you find it, and on the basis of that, you can choose anything you want. So in this case, if you find S square upon SP square, it will come out to be less than 1, right? So you can just take this to be S square upon SP square is less than 1 minus CL. You can go with that. Or if you want to take the test statistic to be SP square upon S square, then accordingly that will also change. So you will have to take reject H naught if SP square upon S square is greater than 1 plus CR. So you can decide on the basis of what information you have in the problem. Okay. Anything you want to know from hypothesis testing?
Now, when a problem is given, what to look forward for to map out the right test?
Yeah. So if the problem.
How do we read the problem to really find out a test?
Yeah. So if the problem, you read the problem, and if it's like if the test is for the mean, like if you want to test the average, then you will have to. Then you have two options: either the Z test or the T test, right?
Now, ideally, you will pick up some problem. You don't need to solve it. Just read
Okay.
out the
Okay.
phrase.
Wait. Oh wait. I will just go through it. Let's go to the 11. Was given. With these problems, it is already given.
Already given us a test, so we don't.
Okay, let's go to practice or
But that's known as normal.
okay, look at the first problem. So it says a random sample of 40 fibers manufactured using process A has a mean length of 16.7 and standard deviation of 0.5. Now you have a random sample of 60 fibers manufactured using process B has mean length of 16.4 centimeter and standard deviation of 0.6. You have to test the hypothesis that the mean length of fibers manufactured using process A and B are the same. Right? So look at the last sentence over here. It says test the hypothesis that the mean length of fibers, right? So you have to test for mean, correct? So if you have to test for mean, you have two options, either the Z test or the T test. So to distinguish whether you have to use the Z test or the T test, you will have to look whether your standard deviation is given to you or not. So in this case, the standard deviation is given to you as 0.5 centimeter, right? For process A and for process B. And you have two samples over here. Like one using process A, one sample has been taken using process A and other for process B. So you can easily identify that it is a two sample test and we have to test the mean. It is a two sample Z test, right?
Yeah, but why we cannot use the chi-square test? Because we don't have the
Chi-square test is for testing of variance, correct?
Yeah.
But
So
here we have to test the mean, test the hypothesis that the mean length of fibers. So for mean, you have just two tests, right? We have still just two tests. That is T test and Z test. So are we able to figure out that it is a two sample test?
yeah, two sample tests, yes.
Two sample test, and you have to test the mean here.
Oh yeah.
So we are using the Z test.
So okay, then we are narrowing down to T test or Z test. So now how do we? You can use either of it, or we got to choose the right thing in this one.
So if the standard deviation is given to you, you will have to use the Z test, right? So generally in T test, your variance is unknown. And for T test, you have just studied one more thing you can take care of. For T test, you have just studied one sample T test. So if you look at the problems that is from two samples and you have to test the mean, you can like just say it is Z test. And if you have larger sample, like both the T test and Z test gives the same result. So it doesn't matter, doesn't really matter. In case of larger sample, your T test and Z test will give you the same result. Okay, so let's look at
the standard deviation is given, so variance also given only, no?
Yeah, given only.
So then we can use the T test also.
You can use the T test also. So what I'm saying is, like, if the sample is big enough, so the result that T test or the Z test gives is almost the same.
But the point here is, among these two, which is the one to choose? I mean, what would be the best thing? T or Z?
So if the variance is known, you go for the Z test.
Okay, so variance is known
The
here.
only thing you have to remember is, if variance is known, go for Z test.
Okay. And variance is not known, then go for T test.
Yeah, right. Now look over here.
Population variance is known, then we have to follow Z test.
If T test.
Yes, ma'am, it's clear.
Yeah, so now look over here. So it says the amount of saturated fat present in 100 grams of cheese and measured, and we have to check whether the two variances are equal. Correct? Again, you have two samples, and what we have to test? We have to test whether the variances are equal.
No, here already F99 is given, so obviously it is an F test.
Yeah. No. From it is already given, and we cannot say it is already given, so we are using F test.
Do we change then? When
You
the
have to,
reference.
no, you have to look at the last sentence. What you have to test? You have to test whether the two variances are equal. So it is a test for variance, right?
Yeah.
So you know that you have two tests for variance. One is if you have one sample, in case of that you use chi-square, and if you have two sample, you use the F test, right? So in this case, you have two samples, so you will use F test.
But why don't we use the chi-square here?
Yeah, because we have two samples. You have brand A and brand B, right? You have two samples.
Chi-square also we use two samples, no?
In chi-square.
Yeah.
Ma'am,
SASD was there, no?
I'm sorry to interrupt, but can we quickly go through the estimation topics? Like for the past few sessions, we are just going through hypothesis, and today also we covered like 2 hours.
Just
okay.
After this, we'll just go to estimation. What you can do is you can just go back, look at the lecture once again, like first two. Okay.
Yeah.
Like whenever it is test for mean, you go for t-test, set test. Whenever it is test for variance, you check for chi-square or F-test.
Okay.
And when to choose what, you just go through it. I have already explained before. You can also go back and just check.
Right. The previous note is uploaded or not?
Which notice?
They just a note page what you are showing to us. Is it uploaded or it is not uploaded?
Which notice you're talking about?
The one what you are writing it now, the red mark you are writing it, no? Is it already included in the portal?
This one?
Yeah, this one.
No, this is not there on portal.
Is it okay to upload?
I mean, you will need the account to open it. I'm not sure if all of you will be able to open it. So
yeah, so it's very useful. It appears to be very close to understanding the mind.
Okay, I will see if.
Yeah, if it's possible, then that would be very helpful.
Ma'am, can you go
Yes,
forward?
Yeah. Okay. So we'll see. Estimation. So we have like 3 parts here. Like one, we are looking at method of moment estimations. Estimator. Second, we have is maximum likelihood estimator. And the third is we have Bayesian estimator. So in case of method of moment estimator, what we do is like we find in this case, we find the distribution of the random variable. We find the distribution of the random variable and we substitute it to the first moment. Like if we have just one parameter in the sample. So let's say if we have Bernoulli samples, let's say x1 to xn, it is Bernoulli p, right? And if we have to find the method of moment estimator for this p here, like what is p here? P is your parameter. P is your parameter that is unknown. That is unknown but fixed constant. So in case of method of moment estimator and maximum likelihood estimator, your parameters theta, they are always fixed. They are always fixed, but unknown constant. Okay. But in case of Bayesian estimator, your parameter theta is a random variable. So whenever we approach the problem for using the Bayesian approach, if we try to estimate the parameter, we assume that the parameter is a random variable and not a fixed constant. Okay. So in case of method of moment estimator, we have like what we do is whatever the mean is. So the mean is going to be what in this case? It is just P. For each of the sample, it is just going to be P, and we substitute it using the method of like first moment. So first moment is what? First moment is just sum over xi. So sum over xi divided by n, that is sample mean. So x bar becomes P. So P hat is your P bar. So similarly, any as you have seen in the mock problem also, like let's say if we have some samples 1 1 0 0 1. So these are the sample that we have observed from some Bernoulli distribution with the parameter P. So if I want to estimate this parameter P, then this is going to be just sample mean. So how many ones that you have observed? It is 3 upon 5. So this is going to estimate a parameter P over here. Similarly, in case of maximum likelihood estimator, in case of max ML estimator, we have some samples, and the first thing that we do is we find the likelihood function. So you have some sample, let's say x1 to xn, and you have the parameter theta. This you write it as product of fx of xi with the parameter theta, and I is varying from 1 to n. Once you write your parameter theta, once you write the likelihood function, this is a likelihood function. This is a likelihood function. Once you write your likelihood function, after that you do the log likelihood. You find log likelihood. If you find the log likelihood, and once you find the log likelihood, you try to maximize the value of this likelihood function. So in order to do that, you differentiate the log likelihood function with respect to the parameter. So in this case, the parameter is theta. So differentiate the log likelihood function with respect to theta, and from there, once you do it, you equate it to 0. Equate to 0, and this will give you the ML estimator. This will give you the ML estimator for the parameter theta. So if we look at the same Bernoulli case, like we have the samples x1 to xn, and if all these are coming from IIT Bernoulli P distribution, then the likelihood function will be given by L of x1 up to xn will be given by product of again fx of xi. So in case of Bernoulli, it is what? For any sample, it is just P, or it is 1 minus P, right? So let us say if W represent the number of successes in n trials, and n minus W is going to be number of failures. So I can just write the likelihood function L to be P to the power W. It means we have observed the success W times, and the failure that is given by 1 minus P n minus W time. So this is our likelihood function. Now the next is we have to do the log likelihood. I will take the log L, and it will be P W log P plus n minus W log 1 minus P. After this, we differentiate the log likelihood with respect to the parameter. So what is the parameter we have? We have the parameter p. So we will differentiate this function with respect to p. So it is going to be w divided by p plus n minus w log 1 minus p, that is 1 minus p, and you will have minus sign over here. And after this, you equate it to 0. So once you do it, you will get w upon p, that is n minus w upon 1 minus p, and it becomes w minus wp equals np minus wp, and this will give you p equals w upon n, and this is nothing but again the sample mean that you get, right? So p hat of the ml, like ml estimator of p, is going to be just sample mean. So this is the process that we use for finding the likelihood estimator for any samples, for any parameter. So these are the method that, so we have seen method of moment ML estimator, and similarly, if we have to find the Bayesian estimator, okay. So if we have to find the Bayesian estimator, so in that case, we will always have to take care that our parameter theta is a random variable. It is a random variable. And if we have to find the posterior density, it is given to be proportional to prior times likelihood. Now the likelihood, how to find the likelihood, we have already seen in the ML estimator, how to find the likelihood function. The same process, you can use it over here. And you will have some prior data about the parameter theta. So let's say my parameter theta has the beta distribution. The theta has the beta distribution with the parameter A and B. So prior is given by the distribution beta AB. So how do you write the distribution of, how do you write the beta distribution? It will be given by x to the power alpha minus 1, 1 minus x to the power beta minus 1. So in this case, A minus 1, B minus 1. So I can just write here, it is proportional to, so in place of x, we'll have here theta. So theta to the power A minus 1 and 1 minus theta to the power B minus 1. And we'll have some likelihood. So if I take the same, let's say the Bernoulli distribution. So in this case, so it becomes theta upon n, right?
Theta upon n and 1 minus theta upon, no, w, theta power w, right?
Yeah, right. So it becomes theta to the power w and 1 minus theta to the power n minus w, right? So I can write these two as theta to the power a plus w minus 1 and 1 minus theta to the power n minus w plus b minus 1. So if you look at it carefully, it again follows it again looks like the beta distribution, right? So how do you write this? It is again beta distribution with the parameter a plus w and the parameters n minus w plus b, right? So the posterior, when the prior distribution for theta, it was given as beta with parameter AB, and the samples were coming from Bernoulli P. In that case, our posterior is also coming out to be beta distribution with the parameter A plus W, comma n minus W plus P. So once you find the posterior distribution, you can find your posterior mean. And posterior mean, so if the distribution is beta, so the posterior mean is going to be A upon A plus B, right? If you have beta distribution with parameter A comma B, the mean is given by A upon A plus B. So all these formulas are already given to you in the formula file. If you can't remember it, that is all right. You can always go back and look over it. Now the postulate mean in this case becomes a plus w upon a plus w plus n minus w plus b. So if you write it, it will become a plus w divided by a plus n plus b. This is a posterior mean. So this is the general method that we follow for finding the posterior. So if you have any specific example, we can discuss here.
Before that, can you explain? So only these three topics is fine, or anything else to look in this week 8 and 9?
So week 9 is generally all this Bayesian part, right? And
Yeah.
what else is there in week 8? It is method of moment, maximum likelihood. You have the bias, finding the bias, right? Bias of an estimator.
Okay.
This part is also there. We have already excluded how to find the error and this confidence interval part.
Okay.
So if you remove these two, only thing that is left is bias, and you know how to find the bias. So bias of any random variable, like it is given by how it is just expected value of theta hat minus theta. So just a simple calculation and find it.
Okay.
So if you remove these two topics, these are the only things that is left.
Okay.
So if you want to solve any example, then we can do it. Like the general method is going to be same. It just your prior will change, likelihood will change. Mock question number 19 to 20. Okay. Yeah, we can do that. So this problem is from mock, and it says waiting time of customers at a restaurant is exponentially distributed with the unknown mean 1 upon lambda. So your random variable x models the exponential distribution with the parameter basically lambda, because mean is given to be 1 upon lambda, and we know if you have an exponential distribution, the parameter the mean is going to be 1 upon the parameter. So x is going to be exponential lambda. And the first question, it say you have some 5 customers over here. So it is 15, 10, 5, 12, and 8. The first question is find the maximum likelihood estimation of lambda. So how do you find the ML estimate of the parameter lambda? So do you want to find this also?
Yes, ma'am.
Okay. So first we will write the likelihood function. So the likelihood function, we have 5 samples here. So x5, it is going to be product of these function, right? Product of the exponential. So it is going to be lambda e to the power minus lambda x. Product xi, I varying from 1 to 5. So it is going to be lambda to the power 5 e to the power minus lambda and sum over xi. If you sum it over, it is going to be 15, 20, 30, it is 50. So lambda to the power 5 e to the power minus 50 lambda. So again, how does it look like? It is nothing but the gamma distribution. Okay. So if you look at the gamma distribution, if you have x follows gamma distribution with the parameter AB, then the distribution of x is given by x to the power a minus 1 e to the power minus bx. So even this looks like the likelihood function looks like something like x to the power a minus 1 e to the power minus bx. So not take that as okay. Yeah, okay, I will take
Yeah,
some
but
other.
after this we have to take the log, right?
Yeah, right. Wait. Yeah. Showing the
Madam, how
trying to
did
the
we get
patient.
minus 50 lambda?
Summation of all the given values, 15 plus
So
10 plus 5
yeah,
plus 12 plus 8.
right. So if you do e to the power minus lambda x1, e to the power minus lambda x2, so lambda will become common and will just sum over xi,
Okay, noted. Thanks.
right? Yeah. So once you find the likelihood function, you will find the log likelihood. So it will be what? It will be 5 log lambda, log of L, minus 50 lambda, right? Now you have to differentiate it with respect to lambda. So it becomes 5 upon lambda minus 50 and equate it to 0. It becomes lambda equals 5 upon 50, that is 0.1. Right. Now the second problem was finding the Bayesian estimator. So second is like find the posterior mean of lambda using the exponential 1 by 10 prior. So the prior of lambda is given to be exponential 1 upon 10. Right? So how do you find the posterior? So again, posterior is given by prior times likelihood. Posterior is given by prior times likelihood. And what is the prior here? Prior is the exponential random variable with the parameter 1 upon 10. So if this is going to be just 1 upon 10 e to the power minus lambda x. So you have the parameter to be 1 upon 10 and you have lambda. Okay. So this times the likelihood. Again, you have you can use the same likelihood.
I have a question here.
Yeah. What was that?
Here lambda equal to 1 by 10, right? So why again we are writing like no e power minus lambda x, right? Should be minus x by 10, right?
Sorry, can you repeat? E to the power?
E power minus lambda x, right? Here lambda equal to 1 by 10, correct?
Okay, so if I have the random variable x that follows the exponential lambda distribution, then it's the function will be given by lambda e to the power minus lambda x, correct? Now I have over here lambda is a random variable and it follows the exponential distribution with the parameter 1 upon 10. So if I have to write the distribution of this lambda, right? So how will you write it? It is the parameter is 1 upon 10 e to the power minus lambda, that's the parameter. So 1 upon 10 times lambda. Remember, lambda is a random variable.
Okay, ma'am. Got it. Thank you.
Right? Lambda is a random variable. Now, the likelihood function we have found in the previous problem. So it is lambda to the power 5 e to the power minus 50 lambda. So I can just write lambda to the power 5 e to the power minus 50 lambda. So once you solve it, so this 1 by 10 constant can be ignored, and it will be proportional to lambda to the power 5 e to the power minus lambda 50 plus
But ma'am,
1 upon
you
10.
put 1 upon 10 in place of lambda.
No, it is right. You are getting confused with the lambda, I guess.
Yes, ma'am. Can you please clear it?
So this is a Bayesian estimator we're talking about, right? And the parameter is lambda. In the original problem, the parameter is lambda, right? But this lambda is a random variable, and what is given us, this lambda follows the exponential distribution, whose parameter is 1 upon 10.
So if you consider some other constant in terms of lambda, then you might find this easy to understand.
Yeah.
Okay, I got this. Okay, thank you.
Got this? Okay.
Okay.
So, okay. So once you do this, you can see that this follows the gamma distribution. So it follows the gamma distribution with the parameter. So if you have a gamma distribution with the parameter AB, its distribution is the function is given by x to the power a minus 1 e to the power minus bx. So it is going to be here 6 comma, this is 50.1. 50.1. So the posterior is proportional to gamma 6 comma 50.1. And if you have to find the posterior mean, you can just do 6 upon 50.1, because the mean of the gamma distribution is given by a upon b. Is it fine? The method is same. You find the sum prior is given to you. You find the posterior, that is prior
Ma'am,
times like here.
6 from where 6 is come?
Where 6 is coming from? Okay. So this look at this. Now what I'm saying is, like, if you have some random variable that follows the gamma distribution with the parameter a comma b, then the distribution function is given as x to the power a minus 1, 1 minus x to the power, sorry, e to the power notice x to the power a minus 1 e to the power minus bx. Okay. You look at lambda to the power 5. Just a minute.
Okay, ma'am. Okay.
You got it?
Yes, ma'am.
Okay.
Ma'am, what are the concepts from which we can expect a question for sure, ma'am?
Goes from week 8 to week 11. Estimation and
Okay, ma'am.
hypothesis testing.
Yes, ma'am. Do we have means will the formula be provided, ma'am? For every required formula will be provided.
You check the formula file. It is whatever formula is given there, the same you will get in the examination hall.
Thank you, ma'am.
Yeah.
Ma'am,
Yes.
I just had one doubt. Can you go to the mock solution 7?
Okay. Yeah, I will just go. Yeah. Which problem?
Seventh one.
Yeah.
Yeah, no, below that, the third one. I'm not able to get this. Like, after you get the p-value, how do you conclude that?
So what is p-value? P-value is the lowest level of significance at which you reject the null hypothesis. Okay.
Yes, ma'am.
Now, from the previous problem, you observe that the p-value is coming out to be 0.04. So it means this is the lowest significance level at which you will reject the null hypothesis, right? Now, the level of significance that is that you have at which you have to check is 5%. Now, 5% means some 0.05, right? So 5% means alpha should be equal to 0.05, and this alpha we get at z equals minus 1.64. Correct. This alpha we get at minus 1.64. So this orange shaded region that you see here, like this is this point over here is minus 1.64, and this is your alpha, and minus 1.69 is the level of significance is the like the at minus 1.69 that we have gotten from the previous problem. So at minus 1.69, your p value is coming out to be 0.04. Okay, so it comes in your rejection region, right? This minus 1.69, this comes in your rejection region, so you can just reject the null hypothesis. So, okay, if one thing you can do is for this problem, you just go to the usual method. Like, just forget about the p-value. You can find the alpha, right? Like, I mean, you can find the C and check whether they
C,
will
yes,
accept.
ma'am. You can find the C.
You can find the C. So, are you able to do that?
Yeah.
Yeah, if you're able to do that, it is fine.
P-value is the lowest significance level till which will reject the null, right? What is the definition for p-value?
P-value is the lowest significance level at which you reject the null hypothesis.
Okay.
So anything else from mock you want to discuss?
Ma'am, question number 9.
Question number 9, okay. All right.
Ma'am, for me, that's a different question.
Okay. So 1, 2, 3, 6, 7, 9. This
Yes, ma'am, this question third one.
Okay.
So here I got the answer as option B, but the correct answer is given as option D. So
no, the correct option is option A here. It was wrong in the portal. It's wrong in the portal.
okay, ma'am. I got answer as option B. So can you explain how it is here?
You got the option as option D or D or B? What do you say?
B, ma'am.
D. Okay. So you got option B.
B is also right, right?
What? Yeah. Repeat again.
B is also the correct option, right?
B is also the correct option.
Yes, ma'am. I got B as the correct option.
No, B cannot be the correct option because see, here it is not symmetric. I mean, you will get one case to be y greater than 100 and other to be y less than minus 100. And if you solve it, so if you solve it, you get something. First is minus 150 divided by 250 and other is minus 350 you get, right? So these two are not symmetric. You cannot do 2 times there. So 2 is the option B is not right.
Okay. Thank you, madam. Thank you.
So A is your correct option. So also in A you can also add f set of minus 350 upon 250 if you want. It's also fine.
Ma'am, can you take question 19 and 20 of mock?
Question 19 and 20. Okay. Can you tell me which problem it is?
It says the number of defects per 100 meter of cloth produced by a weaving machine has Poisson.
So this is from the tutorial. Okay. So it says the number of defects per 10 meters of cloth produced by a weaving machine has the Poisson distribution with mean lambda. Okay, so let's say your random variable x that is modeled using the Poisson lambda, and it gives the number of defects you have per 10 meters of cloth. Now you have examined 100 meters of cloth and you have observed 61 defects. It means in total you are taking 10 n equals 10 such cloths, and you have examined and from there you have observed 61 defects, right? It means out of 100 you have observed 61 defects. In the first problem, you have to use a gamma alpha beta prior that matches your prior belief and find the posterior distribution. So, okay, if the prior is given to be gamma distribution, the prior is given to be gamma distribution, then in that case, okay, also it is given that the prior belief about lambda is that it has mean 8 and standard deviation 2. So, okay, you have the parameter lambda and the expected value of lambda, so is given to be 8 and the standard deviation of lambda is given to be 2. And lambda follows the gamma distribution with the parameter a comma b. So given these information, given the expectation of lambda and standard deviation of lambda and the distribution of lambda, you can find the value a and b. Is this part clear? So the gamma alpha beta distribution, the mean is given by alpha upon beta and variance is given by alpha upon beta square. So once you solve these two equations, you can get your value of alpha and beta and you will get your prior. So if I solve, after solving this, I got my prior to be the gamma distribution with the parameter 16, 2. Now this is our prior distribution, right? Now I have to find the posterior. So how do you find the posterior?
Proportional to prior multiplied by maximum likelihood.
Yeah, so I have to find the posterior and this is given by prior times likelihood. So prior I obtain to be, prior is gamma 16, 2. And what is likelihood? Likelihood is the Poisson random variable. So Poisson random variable, it is given by, the distribution is given by what? E to the power minus lambda, lambda to the power x upon x factorial, right? So what is the lambda given for this distribution? Right. Yeah. So the mean is given to be lambda, and it is saying you have observed 10 such plots and you have observed 61 defects. Okay, so okay, here we have directly calculated, fine. So prior times likelihood, so it is going to be e to the power minus lambda, lambda to the power xi upon xi factorial, and I is varying from 1 to 10. Right? So gamma distribution, it is going to be again x to the power, so in this case lambda to the power alpha minus 1. So lambda to the power 15 and e to the power minus 2 lambda. And this part is going to be, so 1 upon x factorial, you can just ignore because this is the constant term. And I can write this as e to the power minus 10 lambda and lambda to the power sum over xi. I is varying from 1 to 10. So again, if you solve this, you will get lambda to the power 15 plus sum over xi and e to the power minus 12 lambda. Again, this follows the gamma distribution. Again, this follows the gamma distribution with the parameter 15 plus sum over xi minus 1 comma minus 12. So it will be 14 plus sum over xi and minus, it is 12. It is 12. Okay. So this is the distribution for the posterior. Is it clear?
I don't follow.
Sorry?
I did not follow. Is it possible to, because in between I think I got disconnected.
Okay. So what I've written here is you have the prior to be proportional to, posterior to be proportional to prior times likelihood. Now the gamma distribution, like the alpha, the prior is gamma 16 comma 2. And if you have to write the distribution, it is going to be x to the power, I think it's better I write it properly somewhere. I just remove this part. The posterior is given by prior times likelihood. Now what is prior? Prior is your gamma distribution with the parameter 16 comma 2. And the likelihood is your Poisson distribution, that is given by e to the power minus lambda, lambda to the power xi upon xi factorial. I is varying from 1 to n, where n is 10. You have 10 such pieces of cloth. Now, if you write this, it is going to be x to the power alpha minus 1. So in place of x, you have gamma over here. So x to the power alpha minus 1 and e to the power minus beta x. And if you do the product.
Can you explain this? How do you get this lambda to the power 15?
Yeah, so if your random variable is gamma AB, then the distribution of gamma is given by x to the power a minus 1 e to the power minus bx. This is the same thing I've written here.
Okay.
So since the prior was gamma 16 comma 2, this is going to be lambda to the power 15 e to the power minus 2 lambda. Correct? Is this fine? Yeah.
Okay.
And now this xi factorial over here, right? You have like this is going to be constant.
So we can ignore.
We can ignore it, right? Now, if we do the product, you will get e to the power minus 10 lambda, right? 10 times. E to the power minus lambda, e to the power minus lambda 10 times. So it becomes e to the power minus 10 lambda. Correct?
Fine.
And this lambda to the power, it becomes sum over xi, where I varying from 1 to n.
Okay.
Now, this you can write it as lambda to the power 15 plus sum over xi, I varying from 1 to 10, e to the power minus 12 lambda, right?
Okay.
Again, this is nothing but a gamma distribution. Looks something like this: x to the power alpha minus 1, e to the power minus beta x. Does it look like this?
Sorry, I didn't get.
So again, this what you have observed here, like lambda to the power 15 plus sum over xi into e to the power minus 12 lambda. It looks like the distribution. Sorry, the distribution looks like the gamma AB, right?
Yeah.
Okay. So what are the parameters here? What is the parameter A? Can you tell me?
A comma B, like that.
Yeah, A comma B, like that. So what is the parameter A? Using this, can you tell me what is the parameter A here?
15 plus 10.
15 plus sum over xi, right?
Yeah.
Sum over xi, I varying from 1 to 10 and
minus 12.
yeah,
or
here
12.
you have to add 1.
Plus 1. Okay.
Right? You have to add 1 because it is a minus 1 and it is a. So if it is plus 1, then it is going to be just this one.
Okay.
Now what is b?
12.
Minus, yeah, sorry, 12, right? So this is our parameter. So parameter A is 15 plus sum over xi plus 1 and parameter B is 12. Now sum over xi is given to you as 61 in the problem. Look at the problem. It is given as 61. You examine 100 meters of cloth and observe 61 defects. Right? So total number of defects is 61.
Okay.
So this is going to be gamma 16 plus 61 comma 12. So it becomes gamma distribution with parameter 77 comma 12.
Where is that 16?
16, this is 15 plus 1, 16.
Okay. Fine.
So all the problems you have to use the same method, like prior times likelihood. Just use the prior, like write the prior and likelihood properly and decide like what distribution it is.
They're
And
quite
once you
difficult.
find the
Quite difficult. Hope this doesn't come in the exam.
like everything, like this problem will not come in the exam definitely, but something similar to this might come.
Okay. Thank you.
Like all the Bayesian kind of problem is similar to this, like posterior is proportional to prior times likelihood. Some prior will be given to you, likelihood you will have to find, and then find the posterior mean.
Ma'am, is there any shortcut for this? Like in the solution, it is mentioned directly.
Okay, there is no shortcut. In the solution, it is mentioned directly because in the lecture we have already seen if you have a Poisson likelihood is Poisson distribution. If the sample follows the Poisson distribution and the parameter is the gamma distribution, then if the prior is the gamma distribution, then the posterior comes out to be the gamma distribution. But you don't have to remember it. You can go to the usual method. Like in the lecture, a lot of example has been done. Various different priors. You take different priors, and then you find the posterior. So method is same for everything. Uh, if you can remember the formula, you can, if you want, that will be a shortcut for you. But I will if you ask me, you should know the method. That is more better because formula you might forget.
Okay, ma'am. Thank you.
Ma'am, will the end term be similar to mock?
Yeah, the end term, the question patterns and all, yeah, it's very similar to the mock.
Any important questions, ma'am?
No, I cannot tell you that. The study whatever, study week 8 to 11 properly. That's all I can say.
Ma'am, sub question 1 is deleted. That means that is not there in the portion, is it? Moments.
Oh, no, it is not there. That was not there in the mock.
In fact, you should have removed the Bayesian estimate. That would have been more helpful.
Any other problem from mock?
22, ma'am.
What is 22?
A company established two machines, A and B.
What is the doubt here?
If p-value of the test is 0.06, find the value of n.
Okay.
Did you do that before during the session?
No, that part has not been done. So, okay. So, first thing that you have to decide here is like what test you are going to use. Okay. So, is that part clear? Like what test you are going to use?
Yeah, the company established two machines. So basically here you have two groups. So you can use either the Z test or the F test.
Okay, right. Then what test will you use for this problem?
Since the question is related to mean, right?
Yeah.
We use Z test.
Okay. So we'll go for Z test. Fine. Now, what is the test statistic that you will use? Like if you have a two samples Z test, what is the test statistic that you use?
A bar minus B bar.
A bar minus B bar. Yeah, X bar minus Y bar. Right. Now, how do you find? Okay. So the p value is given to you, and you have to find the value of n. Right?
Yeah.
So what is like p value is again a significance level, right? So
you will make one
H0.
using significant level and other using the power or
No.
the
So
error
p
too.
value is called the probability value, and it is almost the same as the way you find the p value is almost the same as finding the alpha, like the type 1 error. Okay, so what does your alpha says? Your alpha says that you reject H0. You reject H0 given your H0 is true. So in this case, it will be like reject H0 if mod of X bar minus Y bar comes out to be greater than C given mu1 minus mu2 equals 0. Fine.
Yeah.
But you have to find the p value here. So in case of like whenever you have to find the p-value, what you do is like in place of c, whatever value you have observed. So in this case, the test if the test statistic value is x bar minus y bar,
Yeah.
right? So what is the value of x bar minus y bar that you have observed? So x bar has been observed as 1.2 liter and y bar has been observed as 1.5 liter,
Yeah.
right? So given the sample, what are the values you have observed? So I have observed this 1.2 minus 1.5. So in place of like if you have to find the p-value, you just substitute your c with whatever you have observed.
Okay.
So if you do x bar minus 5 bar, you will get 1.2 minus 1.5, right?
Yeah.
Now, similarly, you know how to find the standard deviation of x bar minus 5 bar. What is the standard deviation of x bar minus 5 bar?
Addition, sum of the
Sigma 1
variance,
square upon n1 plus sigma 2 square upon n2,
the variance. Yeah.
right?
Yeah, and
So,
the root of that.
yeah, so sigma 1 square is 0.5 square, and you had taken n samples from there. And for bottle B, you had taken 50 samples. So, in place of n2, I have written 50 and 0.4 square upon 50.
Yeah.
Similarly, you will have to do on the right hand side, you will have to divide. And once you do it, you get your, you know, this is your Z, mod of Z. So probability mod of Z is going to be greater than 0.3, whatever you have over here. Right. Now this can be written as 2 times fz minus of 0.3 upon this.
Yeah.
And if you do 2 times here, you will get minus 0.3 this, and once you solve it, you will get n to be something close to 12. Like whenever you get decimal like 11 point something, you just take one integer greater than this. So go to 12. So
The nearest higher integer.
nearest higher integer, right?
Ma'am, always nearest higher integer.
Yeah,
We can't
right.
accept lower.
Ma'am, what if it's like 12.03? So we have to take 13 or we have to take 12?
Sorry?
Ma'am, if it's like 12.03, 12.05, we have to take
Then you
12
have to take
or
13.
13.
13. Yeah.
Hello, ma'am.
Yes.
Ma'am, I have a dot in practice assignment, a question number 10 in PDF. Yeah.
Practice assignment question number
Week,
10. Which week?
week 11.
Week 11. Okay.
Can you go through the PDF? The solutions part, I mean.
Yeah, wait. Practice assignment solution. Week 11. For week 10, you have asked, right?
Week 11, ma'am.
Okay, week 11. Sorry.
I think, yeah, this PDF is that, no?
Yeah.
You just
You are
open
able
that
to
one. Yeah.
see. You are able to see the screen, right?
Yes, ma'am.
The practice assignment.
No, I'm just seeing your PDF page. That is the p-value. The question that you just explained.
Is it visible now?
Yes, ma'am. Yeah, question number 10.
There. Question number
Yeah.
10. This one?
Yes, ma'am. Yeah. Can we do here Z test? I mean, it is Z test is for what? It is for mean and the variance is known, right?
Yeah, right.
So here, yeah. So here it is a variance of sample is given. So can we use a Z test?
Past experience indicates that time required for athletes, it's normal random variable. You can use the Z test also. It will like the result will give come out to be almost the same. I mean, if what is the answer you're getting? You're getting reject H naught. So even if you use the Z test, right, I think it should come out to be reject H naught only.
Ma'am, if we can we take na Z test because it is known, the variance is known, right?
Here it is this sample variance is known.
So Z test is used only for when the population mean
Population
is known.
variance is
Oh,
population
sorry,
variance is.
population variance is known.
You
Right.
can you try using the Z test also, you will almost get the same answer. Just try it once. So here it has been solved using t test. Now what you can do is you can try using Z test.
Even if we use Z test, it's rejected.
Yeah.
I'm getting the C value to be 33.44.
Yeah. So for a quite large sample, like the Z test and t test gives almost the same result. So it's okay to use Z test
Any
also.
one of them, right?
Yeah. Yeah, but you have to take care that the sample is like not very small.
Ma'am, how big would be required?
Sorry?
Greater than 30, I think.
20 is also a good enough number.
So greater than 20, it's okay to
Yeah, you
either
can
do Z or T.
you can take, yeah. Any other doubt? Anything else you want to discuss?
No, ma'am.
No? Okay.
Thank you, ma'am.
Yeah, thank you. Yeah, so if nobody has anything else, we
Thank
can.
you, ma'am.
Yeah, thank you. Thank you all. All the best for your exam.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thanks, Nikita.
Yeah, thanks.